Greetings to all. So let's continue dealing with the UPSC previous year questions. Now the first question for today says two statements are given followed by two conclusions. So there are these two statements given about some particular numbers. Then we are given two conclusions as well. And the question says which of the above conclusions logically follows or follow from the two given statements. So basically on the basis of these two statements, whatever inference we can get is written here, like whether the numbers are divisible by 6 or they're divisible by 4. So on the basis of these two statements, we need to find out whether these conclusions are true or not, like they logically follow these two statements or not. So the first statement here says all the numbers are divisible by 2, and the second statement says all numbers are divisible by 3. So we need to consider these statements to be true, and on that basis we need to check whether the conclusions are getting right or not. So there is a given set of numbers, for example it's written all numbers, right? So there is a given set of numbers that we have, and the statement say that these numbers are divisible by 2 and they're also divisible by 3. The conclusion 1 says that all numbers are divisible by 6. Now there's this property that we have read that in the previous videos we have discussed about it. So we have discussed this thing in previous videos as well. For example, we have a number 99 here. Like we have a number x. And we need to check the divisibility of this particular number x by the number 99. Then what we can do is we can write this number 99 in such form, like the product of 9 and 11 is equal to 99, and the condition of forming these two numbers should be such. The first condition says that both the product of these two numbers should be equal to the number itself. First condition is this, and the second condition says that these two numbers should be co-prime. That is, they should not be common in any table except for one, obviously. So to check the divisibility of this particular number x by 99, like whether this number is divisible by 99 or not, what we can do is we can first divide this particular number by 9, and then we can divide this particular number by 11. If this particular number x is divisible by both 9 and 11, then it automatically means that it will be divisible by 99 as well. This is what this particular thing here means, and same this thing will be applying here. And obviously vice versa is also possible. Like if this particular number is divisible by 99, obviously it will be divisible by 9 and 11 as well. This is pretty basic, but the first case that I explained, that the number should be divisible by both 9 and 11, not just by 1, by both 9 and 11, and 9 and 11, or perhaps the numbers in this case, should be co-prime. So relating this particular thing with the question here, it says all numbers are divisible by 2 and all numbers are divisible by 3. Then it says all the numbers are divisible by 6. So if we try to form such two numbers for the number 6, we can have 2 and 3, right? 2 and 3 are co-prime and their product is also equal to 6. So these are two such numbers. So obviously if this particular set of numbers is divisible by 2 and 3, it will be divisible by 6 as well. So the conclusion 1 is right. And moving on to the conclusion 2, it says all numbers are divisible by 4. Now this is not true, because the reason being, if it would have been the case that all these numbers are divisible by 4 and then they would ask us whether these numbers are divisible by 2 or not, then it would have been a case, because in 4, like we have 2 raised to the power 2, right? So that would be possible, but here obviously we cannot say. And also we can also check by real examples as well. For example, there is a number 6. So 6 is divisible by both 2 and 3. And then they are directly asking us all these numbers are divisible by 4. They're talking about all the numbers. So obviously this is one particular number that is divisible by 2 and 3. But obviously 6 is not divisible by 4. Like the remainder that we receive is not 0 when we divide 6 by 4. So this particular conclusion will not be true. So the only conclusion that we have true, or which logically follows on the basis of these two given statements, is the conclusion 1. So the answer for this question will be only conclusion 1 follows. Now the next question says two statements S1 and S2 are given below, followed by a question. So statement 1 says n is a prime number and statement 2 says n leaves the remainder 1 when divided by 4. And this is the question here that says that this number n lies between 10 and 20. Then they're asking about that what is n. And the question here says which one of the following is correct in respect of the above statements and the question. So which means on the basis of these two statements इनमें से क्या correct है कि इनमें से क्या sufficient है, they are asking to answer this particular question, to get the answer of this particular question, या फिर क्या दोनों ही sufficient है. They are asking this in this particular question. Now we focus upon the statement 1. See, statement 1 says that n is a prime number. So prime numbers, if we imagine, so in these type of questions we basically need to focus upon the types or the possibilities that we can have of the numbers, of the types, varieties, etc. just on the basis of these statements. So statement 1 says n is a prime number. So prime numbers can be like 2, 3, 5, 7, 11, 13, 17, 19 and so on, right? The statement 2 says n leaves a remainder of 1 when divided by 4. तो इतना तो पक्का है कि जो n है वो इन्हीं में से है, like 23 etc. That we are not going to right now because here it says it lies between 10 and 20. So we'll focus on this part later. The statement 2 says n leaves a remainder of 1 when divided by 4, which means when we divide this particular number, the remainder that we receive is 4. So such numbers out of these prime numbers, like we have 5 here, then we have 13 and then we have 17. These are such numbers जिनको कि हम 4 से divide करेंगे, so the remainder that we'll receive will be equal to 1. And the question says if n is a unique natural number, यानी कि हम एक natural number की बात कर रहे हैं which lies between 10 and 20, which means that n is the number out of these 4 numbers present here because ये prime है. But इनमें से जो इन्होंने statement 2 बोला है कि remainder 1, that is just 13 and 17. So we have two answers here, that is there are two such numbers. N can have two possible values, 13 and 17 are the two possible values of n. So they're asking which one of the following is correct in respect to the above statements and the question. They say statement 1 alone is sufficient to answer the question. No, obviously statement 1 alone is not sufficient because just on the basis of n एक prime number we cannot answer this question because there are 4 prime numbers which lie between 10 and 20. तो whenever they're asking about the statement in question, हमें focus करना है सिर्फ उस statement पर और question पर कि क्या सिर्फ इस statement से हम पता लगा सकते हैं कि क्या इस question का answer क्या होएगा. Then we'll focus upon the statement 2 alone. So statement 2 says that n leaves a remainder of 1 when divided by 4. So there are again two such numbers जो कि 10 और 20 इसमें lie करता है. Then the third option says S1 and S2 together are sufficient to answer the question. So S1 and S2 together also are not sufficient to answer the question. The reason being, here we are focusing on the word unique. So n is a unique natural number. So there is no such one unique natural number present here. There are two such natural numbers. So obviously, both of these are also not sufficient to answer the question. If they gave any other such satisfactory clue to identify whether the number is 13 or 17, then maybe they would have been sufficient. So the correct option here will be S1 and S2 together are not sufficient to answer the question. Just because they are focusing on the word unique natural number, and here just on the basis of these two statements, we are having two such answers. That is the number 13 and 17.